Hi, good morning, student. Today we're going to start with chapter 8, Reaction Kinetics. This is the first chapter for semester 2. Consists of three subtopics: reaction rate, collision theory, and factors affecting the reaction rate. Let's look at the 8.1. These are the learning outcomes. Reaction kinetics is the study of rates of chemical reactions and the factors that affect these rates. Reaction rate is the change in the concentration of a reactant or a product with time. Consider a reaction: A produces B. A is reactant, B is the product. When the reaction occurs, the concentration of A will decrease while the concentration of B will increase with time. So as you see in the graph here, the concentration of A decreases while the concentration of B increases. So how do we calculate the reaction rate? Reaction rate equals the change in concentration of a reactant or product over time taken. So consider the reaction A produces B. The reaction rate we can write like in a different differentiation mode, where it's negative dA over dt. The minus sign indicates concentration of reactant decreases with time. Or if for the product, it will be positive dB over dt. The positive sign indicates concentration of product increases with time. So this is the way of writing a differential rate equation in the calculus form. The unit for the concentration, the unit for the reaction rate is usually mole per dm cube per second. However, other unit also can be used like mole per dm cube per minute. The reaction rate can be expressed as average rate, instantaneous rate, initial rate. Average rate of a reaction is how fast a reaction progresses over an interval or in a period of time. So average rate of reaction equals to change in concentration of a reactant or product over time taken for the change to happen. Consider the following reaction. And then they said, by using the following data, calculate the average rate of reaction during the first 50 seconds. So macam mana kita kira? Average rate equals to change in concentration of reactant or product over time taken. So this is for first 50 seconds. So the time will be 50 minus 0, while the change in concentration is 0.0101 minus 0.10120, sorry. So we get 3.8 times 10 to power negative 5 molar per second. Okay. And then we have instantaneous rate is the rate of reaction at any particular time. Instantaneous rate determined from a graph of concentration versus time by the gradient of tangent to the curve at a particular time, while the initial rate of reaction is instantaneous at t equals to 0. So as we can see in the graph here, reactant versus time. So we can find the rate of reaction at T1 and T2 by drawing a tangent to the curve. And then we find the gradient. So we can find the rate of reaction at T1. Likewise, you can find at T2. This is a reaction versus time. We can also find the rate of reaction, the instantaneous rate, from the product versus time. So you can see on the second graph on my right hand side. For example, they want to calculate the rate at T2, then delta Y2 over delta T2. Also tangent to the curve. And then finding the gradient. Okay, this is the instantaneous rate at different time. Okay, you can see there. They calculated at 100 second, 200 second, and 300 second. So from the graph, we can see the instantaneous rate decreases because we are drawing the concentration of reactant versus time. Obviously, you can see the rate decreases. Okay. Now the differential rate equation, this is the PSPM question or Mortometric question. The first graph all is just introduction. Actually, the PSPM question begins with the differential rate equation, which shows the relationship between the rate of disappearance of reactant and formation of product. So consider reaction A plus B produces C plus D. All the capital letters are the species, while all the small letters are the stoichiometric coefficient. So how do we write the differential rate equation? Rate equals to negative 1 over A dA over dt. Negative because it's reactant. And then 1 over A we take from the stoichiometry from the equation, while the dA over dt referring to the species. Likewise, we do for another reactant, B, negative 1 over B, dB over dt equals to. Now, C and D are products, so we use the sign plus. So 1 over C multiply with dc over dt. C small or small case c is for the stoichiometry, while the capital C is for the species product. Okay, and take note they use the plus sign. A, B, C, D are the stoichiometric coefficients. So for example, the formation of ammonia N2 plus 3H2 produces 2 ammonia. So differential rate equation negative 1 over 1 normally we don't write because 1 over 1 equals to 1. Okay, so negative dN 2 over dt equals to negative 1 over 3 dH2 over dt equals to plus 1 over 2 d ammonia over dt. Okay, so the equation shows the rate of disappearance of nitrogen is 1/3 of the rate of disappearance of hydrogen and half of the rate of formation of ammonia, while the rate of disappearance of hydrogen is 3 over 2 the rate of formation of ammonia and 3 times the rate of disappearance of nitrogen. Okay, this is how we interpret the differential rate equation. Okay, so consider the reaction, determine the rate of disappearance of HI when the rate of formation of I2 is 1.8 times 10 to the power minus 6 molar per second. Okay, we shall discuss this in our tutorial class. The further calculation. Maybe I can show the answer here. First, we have to write the differential rate equation. Rate equals to negative 1 over 2 dHi dt equals to 1 over 1 dH2 dt equals to 1 over 1 di2 over dt based on this chemical equation. Okay, and then they give you the rate of rate of formation of I2 1.8 times 10 to the power negative 6 molar per second. We have to find the rate of disappearance of HI. So we just connect the HI with I2 and find the answer. Okay, again I remind you, we will do some examples during our tutorial class. Okay, reaction rate equation, rate constant and order of reaction. Rate equation or rate law. An equation that relates the rate of an equation to the rate constant and concentration of the reactant raised to some powers is known as rate law or rate equation. For example, A plus B produces C plus D. So the rate law will be rate equals to Ka power m B power n. Please take note, the rate law is written for reactants, not for products. Okay, so A is concentration of, bracket A is concentration of A, bracket B is concentration of B. Then K rate constant, M is order respect to A, N order respect to B. M plus N is called as overall order of reaction. Now, what is order of reaction? The power to which the concentration of reactant is raised in the rate law is known as order of reaction. Normally, they are positive integers, 0, 1, 2. Sometimes they can be in fraction, like 1 over 2, 3 over 2, and so on and so forth. Order of reaction usually defined in terms of reactant concentration. So normally refer to the reactant. The reaction orders cannot be predicted from stoichiometry of the balance equation. It must determine experimentally. So take note, stoichiometry bukan diambil daripada persamaan kimia, dia dikira dari segi eksperimen. Okay, tak boleh ambil daripada stoichiometry. For example, the reaction is second order respect to NO, first order respect to H2. Overall is 2 plus 1, the third order. So it's not taken from the stoichiometry. For example, H2 dekat sini kan, kalau kita tengok dalam stoichiometry 2. Tapi secara eksperimen dia first order. So yang betul adalah secara eksperimen bukan dari persamaan kimia. Yang kita ambil daripada persamaan kimia itu adalah untuk differential rate equation sahaja. Okay, rate constant, a constant of proportionality between the reaction rate and the concentration of reactants that appear in the rate law. Magnitude of K changes with temperature. Ini kita dah belajar dekat chemical equilibrium. K can be only altered by temperature. Okay, so units of the rate constant depends on the order of reaction. Okay, ataupun overall order of reaction. Kalau zero order, unit dia molar per second. Kalau first order per second, kalau second order per molar per second. The unit of rate constant can be used to determine the order of reaction. Sangat penting. So rate constant punya unit kena hafal, kerana melalui unit itu kita boleh menentukan tertib tindak balas ataupun order of reaction. Okay, consider the following reaction. H2 plus I2 produces 2HI. Rate equals to K H2I2. What is the unit of the rate constant for K? So rate punya unit adalah molar per second. Concentration punya unit adalah molar. Sebab kita ada dua spesies H2 dan I2, molar kuasa 2. Bila kita ringkaskan, kita dapat per molar per second.